Welcome to Spring LIB.
So first things we want to do here, we got the beltway, we got the woman on it. First thing we want to do is find the time interval required for the woman to travel a certain distance L. How long is it going to take to do that? We want to just have that in terms of L and perhaps the velocity of the belt. So let's start with doing this now. I'm going to say that the velocity of the woman relative to the ground. And we're going to set that equal to the velocity of the woman relative to the first belt, and set that, just add it to the velocity of belt 1 relative to the ground. This is just a relative velocity technique here. And we'll keep building on this. Velocity of the woman relative to the ground. And we'll set this equal to 0, this guy. Velocity of the woman relative to the belt 1, well, she's on it, so it's going to be 0. And then we will set this other one as V1. This belt the velocity of belt 1 relative to the ground, we'll set that equal to V1. And then when you go ahead, you can just have V1 here. And keep in mind, if you want to find their time as well, which we do need, we can use your simple kinematics with a constant velocity, T1 being the length, divided by this V1 that we just found. We always plug that back in if we want to down the road. And this is part A here. All right, let's move on to part B. So we want to be able to find the time interval required for the man to travel the same distance L. But first we need to find the velocity of the man relative to the ground. So we're going to use a similar technique to what we just did a moment ago. So we'll do velocity of man relative to ground. That's equal to velocity of man relative to belt 1. And of course, plus, just like we did on the other side here, velocity of the belt 1 relative to the ground. Excellent. Now the velocity of the man relative to the beltway is going to be considered V2. So we can have V man relative to the ground equal to V2 plus V1. And in this case, the time interval required for the man to travel the distance L, we can go ahead using the same technique here. This T2 equal to the distance that he covered, which is a length L, and then divided by the velocities here, which is the V1 plus the V2. And then the last thing we're going to do is part C. And the first thing we're going to do is find the velocity of the child relative to the ground. Which is equal to the velocity of the child relative to belt 2, plus the velocity of belt 2 relative to the ground. Now the velocity of the second beltway relative to the ground is opposite to the velocity of the first beltway relative to the ground as given in the problem. And keep in mind, the child is also at rest to the second beltway. So keeping that stuff in mind, we can write this as V child to ground equal to 0 minus V1 equals minus V1. And now we want to find the man's velocity relative to the child. So let's keep building on this for a second here. We have velocity of the man to child. And this is equal to the velocity of the man to the ground plus velocity of the ground to the child. And this will then be equal to the velocity of the man to belt 1 plus the velocity of belt 1 to the ground. 1 to the ground. Plus the velocity of the ground to belt 2. plus the velocity of belt 2 to the child. And we can then clean this up. We have equals the velocity 2 plus v1. Just actually, for brevity, I want to write this down here. We have v2 plus v1 minus v1 and plus 0. And this equals v1 plus 2v2 plus 2v2. And at the end here, we can see that the time interval required for the man to pass the child, L, and we can find that by defining a t3 and setting that equal to L divided by the velocity that we had just found here. v1 plus 2v2.